Greetings and welcome. Let's take a look at our fourth critical path method example, and this is material from Chapter 7. The activities involved in a candlelight choir service are listed in the following table. Use the forward pass to calculate the earliest possible starting and finishing time of all activities. Use the backward pass to calculate the latest allowable starting and finishing times of all activities. Calculate the total floats of all activities. And then finally determine the critical path. And so just like the other examples, I'm going to take this in two parts. In the first part, I'm just going to look at the information in the first two columns, the activity, and I'm actually just going to look at the letter assigned to each activity, and then the second column, which contains the precedence. And so I'm going to start by constructing a network as we would normally picture it, where each node will be an activity, and my first task is going to be to make sure I get all of the interconnects between these activities right. And then in the second step, I'll redraw my network, but using essentially the method in the text, where each node is going to be replaced by a 3x3 grid, in which in the first row, I'll list the information in that first part from my forward pass. The bottom row will correspond to the information in step 2, my backward pass. In the middle row, middle cell will be the activity, and then next to that I'll list the float. And so I'll do it in these two stages just because it helps me in terms of making sure I get a nice clean network and making sure I get the connections right. All right, so let's do it. And this one's a little longer. And so let's see if I can get it all down here, or I might need to zoom out. Okay. So as always, I'm going to start with some initial starting node. Okay, and then I'll have some final terminal node, just so I make sure that my network begins and ends at a single node. All right, so activity A has no precedence. So activity A, I'll draw here, say. And so I can go directly from my starting node to A. Okay, then B and C, I see both have a precedence of A. Okay, so I'll draw a node B and I'll draw a node C. Both B and C have a precedence of just A. So if A goes to B and A goes to C. D has a precedence of B and C. So I'll draw D. D has a precedence of B and C. Then E and F are both dependent on D. So I'll draw E and F, both of which just have a precedence of D. Okay, E and F have a precedence of D. G has a precedence of F. So let me draw a G down here, because G has a precedence of just F. Then H and I, J, all just have precedences of D. So where do I put it? I guess it doesn't really matter. I could say stick them up here. Well, where do I want to put? Let me put them. So let me just do H, I, and J. H, I, and J are all just going to have precedences of D. So H, I, J. Then let's do K and L. Okay, so I'm going to do K over here. K has a precedence of J. L has a precedence of K. Then M is going to be dependent on E, G, and L. Okay, so let me write M here. So this is going to be complicated. So M is dependent on, so here's G, here's L, and here's E. N is HLM. Okay, so N I'm going to have this long path from H L M, then final program O. O is going to be connected to, as a precedence of N, okay, but then also have I. All right, so I'm going to have another long path which I connect I to O. Okay, then all of my nodes have some exiting stream, for lack of a better word, but O, so it'll be O that'll connect to my terminal node. Okay. All right, so now I've got this big, complicated network. All right, I'm just trying to see if there's maybe any better way of drawing this. I guess I'd imagine everything would have its advantages and disadvantages. Okay, so let me start with NS. So here's my starting node. Okay, then and let me actually just label my nodes, and then I'll get the interconnects. Okay, so I'm going to start with A. Okay, so for A, I'm going to draw my 3x3 grid. I'll label activity in the middle. And then off of A, I'll have B and C. B and C. And then from there, we had D. Okay, I'm going to go with E and F then next. This should be F. And then E. Okay, then I had KG. So if I weren't doing this on the tab, maybe I would even turn my paper sideways, just to give myself more space to work with. Okay, G, LM. Alright, then N and O. Okay, so I'm running along space. I'm going to do NO my terminal, and then I still need IJK. So I'm going to draw N over here. Oops. N. I'll draw O over here. Then we'll have our terminal node. Okay. And there's just too much. I need HIJ. And those are eventually going to get connected to N and O. So, not where I ideally want them, but let me list HIJ over here. And then let's draw on our path. So that should be all of our nodes. Okay, and so labeling, so I'm going to go from my source to A. then A to B, A to C, A to B, A to C, so then B to D, and C to D. Then D goes to HIJ. D goes to H, I, and J. Okay, and then I'll get the HIJ part later. D then connects to E and F. Okay, F goes to G, and G goes to M. E goes to M. Okay, E also goes to M. J is going to go to K. Okay, let me get the HIJ later, because you might need to move the one. K is going to go to L. L goes to N. Well, L goes to M. L also goes to N. So L goes to M, L goes to N. N goes to O, who goes to terminal. Okay, now I need to see if I can draw on H going to N. So H going to N. I can squeeze down here, I guess. There's H going to N. Yeah, my network looks terrible. I goes to O. Okay, I can get I going to O in. Okay, so again, I might have drawn things differently with a large piece of paper. And J goes to K. So J needs to connect to K up there. Okay, so what I'm going to do is actually let me move J so that it's up top. So I have room for at least J up top. Okay. So D went to J, and then J went to K. Alright, boy, does this look like a mess. Again, maybe in an ideal world, I would have had a second sheet of paper, and I would have turned it horizontally and then drawn that way. But that's what I've got here. Alright, what I'm going to do next is I'm going to go through the table and write down the durations. So A is 2, then B and C are 14. So A is 2, B and C are both 14. D is 3, and E is 70. So D is 3, E is 70. D is E3, E is 70, F is 14. F is 14. Okay, G and H are both 1. G and H are both 1. I and J are both 7. Okay. I and J are both 7. K is 14. then M, L, M, N, O are all 1. L, M, N, oh, N, and O are all 1. Phew. Alright, so I'm going to change my color to red, and I'm going to do my forward pass. So starting at my, starting node, my source, okay, I'm going to start my project at time equals 0, okay, and now I'm going to move forward. So my source node is only connected to A, or A is only dependent on the source. So my starting time, or earliest possible starting time for A will be 0, has a duration of 2, so the earliest possible finishing time will be 2. Okay. Then B and C both only have a precedence of A. So starting with B, B will have an earliest starting time of 2, has a duration of 14, so earliest possible finishing time is 16. Okay. So is it B and C both had 14? Yeah, I guess so. Okay, so looking at C, C is also going to have then an earliest starting time of 2, duration of 14, so earliest possible finishing time of 16. Okay, D has a precedence of both B and C. So when I look at both B and C then, I'm comparing the earliest possible finishing times, and in this case they're both 16. So the earliest possible starting time will be 16. Has a duration of 3, so earliest possible finishing time is 19. Alright, so next we'll look at J. Okay. J only has a precedence of D. So the earliest possible starting time is going to be 9, has a length of 7, so earliest possible finishing time is 26. Okay. I'm going to look at these other offshoots from D. H only has the precedence of D, so its earliest possible starting time will also be 19, has a duration of 1, so its earliest possible finishing time is 20. I also only has a precedence of D, so its earliest possible starting time will be 19, has a duration of 7, so its earliest possible finishing time is 26. If I were to look at E also only has a precedence of D, so its earliest possible starting time is 19, has a duration of 70, so its earliest possible finishing time is 89. F also has a precedence of just D, so its earliest possible starting time will be 19, has a duration of 14, so its earliest possible finishing time will be 33. Alright, then as I build from there, I could go in a number of directions. Okay, but let's look at G. G has a precedence of just F, so its earliest possible starting time will be 33, has a duration of 1, so its earliest possible finishing time is 34. Before I can go to M, I need to go up to K, because M is going to have 3 dependencies. So if I look at K, K has a precedence of just J, so its earliest possible starting time will be 26, has a duration of 14, so its earliest possible finishing time is 40. L has a dependency of just K, its earliest possible starting time will be 40, has a duration of 1, so its earliest possible finishing time is 41. Now if I look at M, M has a precedence of G, L, and E. So what I'm comparing is the earliest possible finishing time of all 3 cases, and the earliest possible starting time then of M is going to be the maximum of these earliest possible finishing times. Right? Because if all 3 activities need to be complete before M can begin, we're going to be held up by that longest one. Right? So see the max is clearly E. So it's M's earliest possible starting time is 89, has a duration of 1, so its earliest possible finishing time is 90. Alright, N just has a precedence of L, so its earliest possible starting time. So actually, hold on. I need to draw in one more line that I missed. M. I'm missing a line. See, M has 3 dependencies. M then is connected to N. All right, N has All right, so here we have a path from M to N. Okay, and then N's going to have M, L, and H. N has M, L, and H. Okay, good. So it just stuck out to me then because M wouldn't have any paths leaving it, and if that was the case, I would then have to also connect it to my terminal node. Okay, so let me get my red pen back. So when I look at N has precedence of M, N, and H. Okay, so I'm looking at the earliest possible finishing times of H, which is 20, M is 90, and L is 41, and my earliest possible starting time is going to be the max, which is clearly that of M of 90. Okay, have a duration of 1, so its earliest possible finishing time is 91. O has a dependency of I and N. Earliest possible finishing time of I is 26. N is 90, so I'm looking at the max, or N is 91, so I'm looking at the max, so the earliest possible starting time then of O is going to be 91, has a duration of 1, so its earliest possible finishing time is 92. So that tells me then that this project could be completed in 92 days. Alright, so my project can be completed in 92 days. What I'm going to do next is I'm going to do a backward sweep and figure out the latest possible finishing and starting times. Okay. Alright, so the way this works is going backwards. So the terminal node is only connected to O. So the earliest possible finishing or latest possible finishing time for activity O for this job to be completed on time is 92, has a duration of 1, so its earliest possible starting time is 91. Okay, and then it's, where do we, let's follow this, this madness, if you will. And it's a little more complicated because the way I've drawn this path. So that's O. Okay, so then working backwards, going into O is going to be I and N. Okay, I'm just making sure I had, okay, so that's O. Okay, so now going backwards, okay, so I needs to be completed before O can start, right? So the earliest or latest possible finishing time then of I for O to begin on time is going to be 91. Okay, has a duration of 7, so is this 84. Okay, latest possible starting time then of I is 84 in order for it to complete on day 91 for O to begin on time. Alright, so now where I need to keep track of things is I can't just jump to D because I need to get all of these dependencies on D first so that then I can choose the minimum. And sorry, I've got so many arrows. I'm just trying to keep track of things. It's gets a little complicated, if you will. Okay, so that's O dependent on I. O is also dependent on N. Okay, all the other arrows go in, so I'm looking at this arrow out of N. Okay, so in order for O to begin on time, the latest possible finishing time for N is 92. 92 has a duration of 1, so latest possible starting time is 91. Okay, so that gets me to N. So now from N, I can look at H. Okay, so N is dependent on H. So in order for N to begin on time on day 91, H needs to be completed by day 91, has a duration of 1, so it needs to begin by day 90. Alright, so now looking back from N, okay, so N has a dependency of M and N. And I'm well, actually, M, N, and L. Shoot, I am confusing myself with all these arrows. Okay, so H, good. Okay, so now if I look at M and L, okay, so H just has the one outbound arrow to N, same with M and L. So in order for N to begin on time, M needs to also be completed by day 91, has a duration of 1, so it needs to begin by day 90. Looking at L, okay, so I can label M because M just has that one outbound arrow going to N. Okay, but now I also have this inbound arrow to N coming from L. Okay, but L is also connected to M. Okay, so now I need to compare the two. So when I look at L, okay, L is going to be a precedence for both M and N. So if I were just to look at this first arrow, I'd say, okay, the latest possible finishing time of L is 91, and the earliest possible starting time, or latest possible starting time then is 90. But the issue with that then is it wouldn't work out in terms of looking at the connection for M. So L's connected to M and N. So when I look at the latest possible starting times for M and N, for which it's both connected, I'm looking for the smallest one. The smallest is going to be 90, right? Because it needs to finish by day 90 so that M can finish on time. Okay, and then that'll also work out with N because it'll finish a week earlier than is necessary for N. So L needs to begin by day 9 or end by day 90, has a duration of 1, so it needs to begin by day 89. All right, so let's look easy because then K I have in series, so K is just connected to L here. So if L needs to begin by day 89, K needs to begin by day 89. It has a duration of 14, so is at 75. It needs to begin by day 75. Okay. So then going from K to J, I can, because J is just connected to K. So J then needs to end by day 75, has a duration of 7, so it needs to begin by day 68. Phew. Okay. D, I'm going to have to wait until I get everything else labeled, because D has a lot of connections. Alright, so E is just connected to M. So the latest possible finish date of E for M to begin on time is going to be 90. Has a duration of 70, so its latest possible starting time is 20. Okay, M just has the single connection to G, or G just has that single connection to M. So G needs to end by day 90, has a duration of 1, so it needs to begin by day 89. And then looking at F would need to begin by day, or need to finish by day 89, duration of 14. So needs to begin by, is it 65? No, 75. Yeah, 75. Okay. All right. Now D is going to be our big holdup because D needs to be completed before J, E, F, I, or H can begin. So what I'm looking at is the smallest starting time. Okay, so I'm looking at the smallest or the minimum of the latest possible starting time. So I have 68, 20, 75, 84, 90. So D needs to begin by or end by day 20 so that E can begin on time. So it needs to end by 20. Has a duration of 3, so it needs to begin by day 17. All right, so now B needs to be completed before D can begin. So it needs to end by 17, has a duration of 14, so it needs to begin by day 3. C is going to be exactly the same. Okay, so then, oh shoot, I'm going to be off a day, so I'm going to need to try and figure out what I missed. All right, because then A would need to begin by 3, has a duration of 2, and so that's going to be 1. Okay, well let me. So I need to go through it and check this just to make sure everything. Make sure I've got everything. So terminal node. So this project takes 92 days. So going back then to O, which is the only one connected to NT, its latest possible finishing time is 92. Duration of 1. Needs to begin on day 91. So I'm looking backward from there. Okay, easiest one is I, because I just has one outbound connection to O. So it needs to end on day 91. Duration of 7. That brought me to 84. Okay, so this is just a complicated network. So I need to make sure, I'm going to go through and make sure I actually have everything right. Okay, I can't go from I to D because of all of D's dependencies. Okay, so then from O, I can go to N. All right, because N just has one outbound connection, and that's O. So O or N needs to end by day. Oh, here's my issue. If O needs to start by day 91, N needs to begin or end by day 91. So here's where my count's off. Okay, so it's going to be 91. So I goofed that up. And so it needs to begin by day 90. And so then, yeah, that's where I, so that, shoot. So you see me making this mistake. Okay, so that's 90. Has to begin at 90. That's 91. Okay, so then N's dependent on H. So if I start with H, so this needs to be 90, and that has a duration of 1, so that's 89. Okay, bam. So then I have H. So I'm looking in the opposite direction. M only has the one outbound to N, so this has to be 90. This is 89. Okay, then L has M and N, so I'm looking at the smallest of the latest possible starting times, so that's going to be 89, so it needs to be done by 89, and so then that's going to make it start at 88. Okay, and then going backwards, so then this is 88 and 74. Bam. And then J is going to be 74 and 67. Bam. E, boy, I'm sorry. So this is 89. And then 19. G, so this is 89 and 88. Good thing is it's a lot easier the second time. 89 and 88. And so then this is 88 and 74. And so then D, looking at the minimum, so there's going to be E, right? So now, because everything is like off by 119 and 16. So these are all going to be 16, 16, and 2. Okay. and then this would be 2 and 0. All right, so my check was this should have the latest possible starting time of 0, since it's the only node connected to that source. All right, so it wasn't so bad going through the second time. Now I can go through and calculate my floats. Okay, so earliest and latest possible starting and finishing time of A's are the same, so I'm a float of 0. Okay, so I'm going to label that. That's going to be a critical activity. Okay, B and C, earliest and latest times are the same, so that also both of those activities also have a float of 0. Looking at D has a float of 0. The earliest and latest possible starting and finishing times are the same. So there's another critical activity. So now it just depends on where I want to go in my web. Let's go up to J first. Okay, so J, the earliest possible starting time is 19. The latest is 67. So let's see, that's going to be 48. So that has a float of 48. Okay. And so, what I mean by a float of 48 is if the project begins or activity begins anywhere in that window of day 19 to day 67, that window of 48 days, my project will be completed on time. Okay. E, if I look at E, earliest and latest possible start dates are the same, or times are the same, so that's going to be a critical activity. K, 26 and 74, 40 and 88. So I'm going to have another float of 48 days. Okay, so it could begin anywhere in that 48-day window. L, likewise, has a float of 48 days. Okay, a difference of 48 days between the earliest and latest start times. F, so now we're going to be even bigger, right? Earliest possible start time is 19. Latest possible start time is 74. Okay, so that's going to be 55, right? Yeah, 55. So this has a float of 55. G, 33 to 88. 34 to 89, so 33 to 88, again, it's 55, so it's the same float as F. Oop. Okay. M, earliest and latest possible times are the same, so it's going to have a float of 0. So it's going to be critical. N, earliest and latest possible starting times are the same, so it has a float of 0. O is the same, has a float of 0. I, 19 to 84, or 26 to 91. So we're looking at 65. This has a float of 65 days. And then 20 to 90, or 19 to 89, a float of 70 days. Okay. All right, so my critical activities are all labeled with an asterisk. So what's meant by critical activity is that activity has to start and end at that precise time in order for my project to be completed on time in 92 days. Whereas the ones that don't have a star, so J has a float of 48 days. There's a window of 48 days during which that project or that activity can begin, and my project will still end on time. Okay, look at H has a float of 70 days. So I have a 70-day window during which I can begin that project or that activity and still have the project end on time. All right, so then in terms of critical path, all right, so I can link through my critical activities. So my ABC, all right, ABC, D, E, M, N, O. Yeah, so my critical path, all right, is going to be ABC. Okay, so I'm just essentially linking my critical activities. A, B, C, D. I'm going to list B and C because D is dependent on both B and C. A, B, C, D. And, what's interesting is D is dependent on both of these. So if I wanted to try and speed up, if I wanted to try and accelerate this, I can't just speed up B because then D will be held up by C. So I'd have to speed up. I would have to speed up B and C by the same amount, right? So accelerate them by the same amount. So then D, where these other ones, it's just a single dependency that I would be looking at. So then I have E M N. EMN O. Okay, so if I want to accelerate this project, I'd be looking to accelerate A, D, E, M, N, O. Or if I wanted to speed up B and C, I'd have to do them both by the same amount. Okay, those are my critical activities though, because there's no float. They need to begin and start at that specific time. All right, this one was just a little more complicated in that the network was a little more evolved, and it was a good example of when I did my backward pass, I ended up getting the latest possible starting time of A, which is impossible. So I went back and checked, and I had made a small error, and so then quickly fixed everything up. Okay, so when you go through it, right, I want to make sure when I get to A that my latest possible starting time is 0. So hopefully that helps. And if you have any questions, let me know.